In solving polynomial equations, some solutions were a combination of real numbers and complex numbers. We saw that quadratic equations always have two roots. Either two complex solutions, one double root, or two real solutions. With cubic equations, there were always three solutions, one real and two complex solutions. Three real solutions, two of which are double roots. Or three unique real solutions. This is a consistent pattern with polynomials and gives rise to the fundamental theorem of algebra. According to the fundamental theorem of algebra, a polynomial of degree n will have n roots, some of which may be complex. Let's look at several examples of higher degree polynomial equations to determine the number and type of roots they have. Here is a fourth degree graph. It doesn't intersect the x-axis. There are no real roots. So where do we find the four roots that the fundamental theorem of algebra says are here? There are two pairs of complex roots from these quadratic factors. Here is a fifth degree graph. It intersects the x-axis once, which accounts for one real root. So where are the other four roots? There are two pair of complex roots from these quadratic factors. Now we can bring together all the tools we have in our arsenal to solve polynomial equations. Look at this fourth degree polynomial. Using the rational root theorem, we identify all the possible roots. First, find the factors of 9, which is p. Then find the factors of 8, which is q. Finally, find all the possible linear roots of the polynomial. In this case, there are a total of 24 possible roots. To quickly run these 24 roots through synthetic division, you can create a spreadsheet template that does all the calculations. Here's what it would look like. This screen shows the polynomial coefficients, the input cell for testing a root, and the formulas to use to perform the synthetic division. Here are three sample calculations, one of which reveals one of the roots. So we can write the quartic function as the product of a linear factor and a cubic. We can now factor the cubic. Remember that a cubic will have at least one real root, and the possible roots are the same as the ones for the quartic. Running these possible roots through our spreadsheet synthetic division calculator, we get a root of x plus 1. We can rewrite the original polynomial as the product of two linear terms and a quadratic. We check the discriminant of the quadratic to see if there are any real roots. There aren't, so the remaining two roots are complex. You now have the mathematical tools to solve polynomial equations. But you can also rely on technological tools. For example, some graphing calculators have equation-solving capabilities that allow you to find the solutions to polynomial equations that include complex roots. For example, using the TI-Inspire with the quartic equation we solved earlier shows the same solutions we found.